All right, we're going to do problems 1 through 5 on review day number 17. First one here gives us a function, and it says at what points does the line tangent to f have a slope of 1/2? So in other words, when does the derivative equal 1/2? So we're going to take the derivative of this, which is a quotient rule, bottom times derivative of the top, minus top times derivative of the bottom, over bottom squared. And this is going to give us x plus 2 minus x. So really it's going to give us 2 over x plus 2 squared. And we want to know when does that equal 1/2. So if I kind of cross multiply here, I get 4 equal to x plus 2 squared. Now if you were to take the square root of this and get 2 and then subtract, you would get x equals 0, and then you would probably pick a. And that's the sneaky part of this problem. You're doing everything really well, but when you take the square root here, you have to consider both the positive and negative square root of that, because both of those squared could equal 4. Which means now when I subtract 2 from this, if it's positive 2, 2 minus 2 gives me x equals 0. But if it's negative 2 and I subtract 2, I could get negative 4. And so both of those work, and if I put those back in, I end up with an answer of C for that one. So you gotta be real careful on that one. Again, if you picked A, you're doing great work. You just got caught on that little thing there. The second one says, which of the following gives us a horizontal asymptote of y equals 5? Anytime you see horizontal asymptote, they pair that almost always with the limit as x goes to infinity. So in other words, let x get super big, and which of these, as x gets bigger and bigger, would level off to a value of 5. Now, sign always goes between 1 and negative 1. So if we take something that's no bigger than 1 and divide it by something super big, this is going to go to 0. So not 5. If we let x get super big, 5 times something super big is going to go get bigger and bigger. So that's going to go off to infinity. This one has a vertical asymptote at 5, and that might have thrown you off a little bit. They're asking for a horizontal. If we let x get super big, this is going to go to 0. On this one, if we let x get bigger and bigger, the top and bottom have the same degree, so one won't dominate the other, but then it goes to the coefficients, and 5 divided by negative 1 would go to negative 5. So close, but not what we're looking at. This is the one. If we compare 20x squared with 4x squared, those are the ones that are going to dictate what happens here, and over time that's going to go to a value of 5. So E is the one that has a horizontal asymptote. So you had to understand what this was really asking for at first, and then be able to kind of process all of them in that light. This one says, what's the absolute maximum value of this function here? So anytime we see absolute maximum, we got to think critical point first. So I'm going to take the derivative, which is can do as a quotient rule, bottom times derivative of the top, which is 1 over x, minus top times derivative of the bottom, which is 1 over bottom squared, gives me, these x's cancel, 1 minus natural log of x over x squared. And I want to know when that equals 0. That would be my critical points. Now technically 0 would be a critical point because it could be 0 or undefined. But if you look at your original function, you can't take the natural log of 0. So we won't consider that. So really it's just the top. When does 1 minus natural log of x equal 0? And that's when natural log of x equals 1, which is at x equal e. Okay. Now if you went looking for e, they did you a favor in that they didn't put it on there. That would have been real sneaky if that was a choice, because this is just where it might occur, right? This is not actually the actual maximum. What we want to do then is put this back into the function. So what is f of e? And that would be natural log of e over e, which is 1 over e. That is a choice. Now, the other thing that we want to just kind of consider here is, are we confident this critical point was the maximum, right? So you might want to take your derivative and check something before e and after e. So if you were to put, say, 1 into this, natural log of 1 is 0. So I get 1 over 1 squared, which is 1. I get a positive. So the function is increasing up to e. And then if we put something bigger than it, I mean, you think, pretty large natural log of something really big will be bigger than 1 for sure. So 1 minus large number will be negative over positive. We'll get a negative value there, which means our function is decreased. So we're increasing up to that value of e, decreasing after it. So definitely this is a relative maximum. And because it never comes back from decreasing, it'll be our absolute maximum. So we're real confident now. Even if you didn't do the check, you got away with it there, but very confident that 1 over e is our maximum on that. 13 says we got this function x squared e to the times e to the kx. We want to know when would we have a critical point at x equal 2/3. So critical point means that our derivative will be 0 or undefined when x is 2/3. So what we have to do is find the derivative of this. That's going to be a product rule. Derivative of x squared times this as is, plus x squared times the derivative of this, which will be e to the kx repeated, times the derivative of kx, which is k. All right. Now what I want to do is two things. I want to set this derivative equal to 0, and I want to put 2/3 in for all these x's. So 2 times 2/3 would be 4/3, e to the 2/3 k, plus 2/3 squared, that'll be 4/9 times k times e to the 2/3 k. Okay, I want to know when this equals 0. Now I can pull an e to the 2/3 k out, which gives me 4/3 plus 4/9 k equal to 0. Now the nice thing about this is that the e is always a positive number. Positive number to any exponent will stay positive. So really this cannot be 0. So the 0 is going to happen right here. So I want to know when 4/3 plus 4/9 k is equal to 0. If you subtract 4/3 and then multiply by 9/4, we're going to get a negative 9 divided by 3. We can get a negative 3 for that. So A is our answer. So a little sneak. I mean, if you did the product rule, good for you. If you set it equal to 0, good for you. Maybe the 2/3 wasn't obvious to you at first, or maybe you left this k out. A lot of places that could have gone south for you, right? But that's how we do that one. And then we get this last one here, and it says g is a function so that its derivative is equal to this, which of the following must be true. Now there's a few things that would help you out in here. First, if you knew what e to the negative x t squared looked like. So if you kind of put 0 in, you see that you hit a value of 1 at first. If you were to put 1 in, you get e to the negative 1, or 1 over e, so about 1 over 3, 1/3. And then as t gets bigger, this gets smaller and smaller. It approaches a value of 0, but it's never going to be negative, and it's never going to be 0. So it's getting smaller and smaller. So this function is decreasing, but that's not important. What is important is how we interpret what's going on here. So first off, g prime is the area from 0 to x. This area is always positive, right? It's constantly positive the entire time. So g prime is positive. Secondly, the second derivative of g would be the derivative of this, which would be e to the negative x squared. And again, while that's decreasing, that doesn't matter. We're just saying, is this positive or negative? And this function is always above the x-axis. So g double prime is also always positive. So that's what, even if you knew what this looked like, you could get really twisted around with the idea that that's decreasing. So we have a positive first derivative. That means g is increasing. We have a positive second derivative, which means it's concave up. And so that gave us option A as our answer.